Alright, for this next video we're going to be talking about rational functions. Basically what a rational function is, it's an equation where the top and bottom parts of the denominator are both polynomial functions. And one stipulation is that the bottom function cannot be equal to 0. That's just common sense way back from the day when we were doing domain and range, where we know that the bottom can't be 0 because we can't divide by 0. And a big topic that deals with rational functions is the concept of asymptotes. Now, I think you've seen or heard of asymptotes before, but just in case you forgot, asymptotes is basically an imaginary line on a graph that a curve will approach and get infinitely close to, but it doesn't usually cross. It will cross sometimes for horizontal asymptotes, but a vertical asymptote it will definitely never cross. The first asymptotes we're going to look at is vertical asymptotes, and it's important to realize that a curve will never, ever cross a vertical asymptote. This is because when we're trying to find the asymptote, we're going to be focusing mainly on the bottom. We're going to take our denominator and set equals 0 and find the x, that's going to be a vertical asymptote. So we're going to take our denominator, set equals 0, and once we solve for x, that's going to be a vertical asymptote. So this is pretty easily factorable. So we got x minus 3, x plus 1 equals 0. That means x equals 3 and x equals negative 1. Okay, so our vertical asymptotes. Whoops. We have vertical asymptotes at x equals 3 and x equals negative 1. So if we were to look at the graph for this function, which I'll show you guys how to graph this later in this video, you'll see at our vertical asymptotes, these values, this is x is negative 1, and this one's x equals 3. Our graph gets infinitely close to it, but it'll never touch. Okay? So it'll get infinitely close to the vertical asymptotes, but it will never touch. Now here we see a horizontal asymptote, which I'll show you how to do that in the next slide. Right, to find a horizontal asymptote, you would just divide the leading coefficients, provided that you listed the powers from greatest to least. So here we have all the powers listed. We have x squared, then x, so they're in order. Here we have x squared, then x, then 3, so they're in order. So now, to find the horizontal asymptote, we're going to divide our leading coefficients. So horizontal means the equation is going to be y equals. So let me just change my color. We got a horizontal asymptote. Y equals the top leading coefficient of 3 over the bottom leading coefficient was 1, which equals 3. So that's a horizontal asymptote. But it's important to note that not all the time are these leading exponents going to be the same. I'll show you what to do next. Okay, now here in g of x, you'll notice that that leading exponent at the top is a little bigger than the leading exponent at the bottom, whereas over here the exponents are equal. So we just divide the first two coefficients. So to combat this, back in synthetic division, if we were missing a term, we would do a placeholder. We're going to do the same idea here. So we're going to replace, so g of x, it's the same thing as x squared plus 2x over 0x squared minus 4x plus 8. Alright, now we have the same exponents, so now we're going to divide the leading coefficients. So y equals 2 divided by 0. Well, that's not possible. Okay? So it's safe to say that if the leading exponent at the top is bigger than the bottom, then there's going to be no horizontal asymptote. Now look at the next example where the leading exponent on the bottom is bigger. Okay, we're going to do the same idea. We're going to have a placeholder. So we have 0x squared plus 0x plus 4 over x squared. Oops. Okay. Now our exponents match, and now we can just divide the leading coefficients. So we have our horizontal asymptote. Y equals a 0 over 1, which equals 0. So here, if the leading exponent at the top is smaller than the leading exponent at the bottom, your horizontal asymptote is right away going to be 0. Okay, last but not least, we have slant asymptotes. This is when the leading exponent at the top, so our leading exponent here is 3, is 1 more than the slant asymptote on the bottom. So right here. So the leading exponent on the top is 1 more than the bottom, so now we can do slant asymptotes. And we find the slant asymptote by doing long division. Okay, so we're going to take our divisor right here, and we're going to divide it into our dividend, and we're going to see what our quotient is going to be. Our quotient is going to be our slant asymptote, and our remainder, we're just going to disregard that because that's not going to affect us much. So after you do long division, we have our quotient, we have our remainder, and our slant asymptote is going to be our quotient here. Slant asymptote is kind of the equation of y equals. So for our slant asymptote, y equals 1/3 x plus 2/3. Okay, now in class we're going to do a lot more practice problems of these, but I just wanted you to have an idea of what a vertical, horizontal, and slant asymptote were. Alright, after watching this video, you should be able to try, at least try, page 321, numbers 9 through 14.